David Smith here with another flipped classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen. Today's topic, translations, which are also called slides. This is our first lesson in our transformations unit. Starts off easy, gets a little bit more complicated as we go. So a slide is simply moving a point or a geometric figure or a function by sliding it somewhere on the coordinate plane. Okay, so we're going to start just by sliding a point. Here's my coordinate axis, x, y. We're going to start with my point P, some coordinates, x, y. This could be 2, 3, or whatever it might be. And we slide it h over and k up, and that gives us our new point, P prime. And I went h over, so the new coordinate is going to be x plus h. That's whatever value that was. And the new y coordinate is going to be y plus k, whatever value that was. Pretty straightforward. We have some notation here. Point P, x, y, translated over h, k, and this is called the translation vector. So we write that. It's kind of maybe confusing because you write the x coordinate on top of the y coordinate instead of in typical like coordinate point format. And then we end up with point P prime, which is x plus h comma y plus k. Okay, let's do a quick example. We're going to do a triangle. Okay, so follow along with here and then we'll go get over on the graph and get it done. So triangle OAB has vertices like the corners of the triangle. Point O, which is 0, 0, point A, which is 2, 3, and point B, which is negative 1, 2. So that's our triangle, and you can see I've already put that on the graph over here. Okay, now it's going to be translated by the vector 3, 2. Okay? So the instruction for this kind of problem is going to be graph triangle OAB and its translation under 3, 2. Okay, so there's the setup. You might see a homework problem like this, very much like that. Okay, so let's take a look. I need to graph my new points, my O prime, my A prime, and my B prime. So that's what I'm going to do over here. This is pretty straightforward. Here's my point 0, 0. I'm going to add 3 to the x and 2 to the y. So that's just going to make this point 3, 2. So that's O prime. Point A starts off at 2, 3, and we're going to add 3 to the 2. So that's going to be 5, and 2 to the 3. So that's 5, 5. So all I did is I used this translation to change this point to A prime, which is now 5, 5. Okay? Finally, let's translate point B, which is negative 1, 2. We're going to add 3 to the negative 1 and get 2, and 2 to the 2 to get 4. So now I have my 3 new points. Let's graph them up. So O prime, my first one, is going to be 3, 2. So that's right there. Let's label that O prime. My second point, my A, is going to be 5, 5. So 5, 5, right up there. That's my A prime. And my third point, my B prime, is going to be 2, 4, which is right up there. B prime, connect my triangle up. So there's the slide. Remember, translations are slides. So we went from OAB to O prime, A prime, B prime. Pretty straightforward. Okay, let's do another example. Different kind of translation or different kind of question. This one is, what translation maps the point 3, negative 1 to 0, 10? So instead of mapping the new point, you're given the new point and you have to figure out what the translation is that does that. Pretty straightforward. So I wrote it out in our notation with our translation vector missing. What do I need to do to the x term to get to the translated x term? I'm at 3, I'm going to 0, so that's minus 3. What do I need to do to get from the y term to the new y term? I'm at minus 1, I'm going all the way up to positive 10, so that's 11. Pretty straightforward. Okay, so you're going to map translated points, and polygons. You could get a square, you could get any number of figures to do that. But you're also going to translate equations. This is where it gets a little bit more tricky. So let's take a look at this one. What translation maps y equals x squared? Remember, this is our basic parabola. So you should be thinking about what you know about this parabola. This is assumed prior knowledge for this course. So how do we map y equals x squared to this new one, which is y equals parentheses x minus 1 squared plus 7. So to do this, you have to remember some things about parabolas. I'd like you to pause the video and see if you can figure this one out. The steps are not hard, you just have to see what the difference between these two functions is. Okay, so here's the thing to realize. The vertex of this one, this is the basic parabola. The vertex is 0, 0. Okay, so this parabola looks like this. It's going right through the origin with the vertex being right there at 0, 0. This is the most simple parabola there is. This parabola is just a variation of this parabola, and it's written in vertex form. So you can pull the vertex right out of it by inspection, which means you can just look at it and get the vertex. Remember, it's HK, but you switch the sign of that. So this becomes 1, 7. So otherwise, both of these equations are the same. This one just has a vertex in a different spot, like 1, 7, sort of up there. Okay? So you can see that we translated the vertex that way. So to finish this question, the translation that maps this function to that function is 1, 7. Because we moved our vertex from 0 to 1, so that's the 1, and from 0 to 7, so that's the 7. Okay, one last example. Different type of problem. The point, 6, 2, is translated by the vector 2, negative 2. Okay, so we know how to do that. But now they're asking us, how long is the vector? Okay, so this is a geometry problem, and the way I solve this is by getting it on the graph and taking a look at the situation, and then it's going to be a straightforward application of the Pythagorean theorem. If you think you can get there, pause the video and give it a shot. Okay, let's see how you did. Okay, so here I am at 6, 2. I'm going to translate it 2 to the right and 2 down. So I'm going to go 6 over 2, which is going to put me at 8, and then 2 down, which puts me at this point, which is 8, 0. So I've gone to 8, 0. I've gone from 6, 2 to 8, 0. Here's the vector. They're asking how long is that vector? So what I'm going to do is break this out and draw my triangle. Which is just that triangle. There's a right angle there. So the vector here is that, or C, if it was a right triangle. Now, how far have I gone over? I've gone over 2. And how far have I gone down? I've also gone down 2. So my x, I can use Pythagorean theorem, it's going to be 2 squared plus 2 squared equals x squared. Now I just solved that for x. So this is 4, that's 4. So 8 equals x squared. So x equals root 8. Now, if you think you're done, remember that you're also held accountable for putting your roots in simplest form. So I'm going to break this out right now. 8 is 2 times 4. We factor so we can pull out some perfect squares. 4 is a perfect square, so the square root of 4 is 2. So this gives us 2 root 2. Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below. And if you'd like to help me grow my YouTube channel, please click subscribe.